Revelator John.
Hello Revelators, welcome to Revelator John for another weather theory video. So today I'm talking about wind. What is wind? So wind is essentially just the movement of air from one location to another location. Now it can be a fast wind, as in a very fast wind, for example in a hurricane, tropical storm, or a tornado, that kind of thing. Gale force winds, or it can be a very light wind, a breeze, for example. Essentially, it's exactly the same thing. The only difference is the speed at which it's moving. So, what causes the air to move? What causes this wind? Okay, so there are quite a few different things going on at the same time. But if we take the major difference, or the major cause, I should say. The major cause of wind is a pressure differential. When you have a higher pressure air mass, a high pressure, and that air from that high pressure wants to move out, and it wants to move towards, occupy the space of a lower pressure. High pressure to low pressure. The steeper the gradient, in other words, the greater the differential between the pressure systems, the faster the wind. Okay, for example, it's exactly the same if you try and pour some water down a shallow gradient, the water will trickle down. If you try and pour the water down a steep gradient, it will flow down. It's exactly the same thing. Fluid dynamics, whether it's air, liquid, it's virtually exactly the same. Okay, so the steeper the gradient, the greater the differential between pressures, the greater the wind velocity will be. So what else can cause wind? Well, temperature has a huge effect on wind. It can affect the wind both at a local level, but also at a big air mass level as well. So, coupled with a pressure differential, we can have changes in air density, okay, with cold air being really dense, warm air being really a lot less dense, of course. So that difference in density can also, coupled with the pressure, they're not mutually exclusive. They always interact with each other, of course. The colder dense air wants to occupy the area occupied by the warm, less dense air. So temperature, density also plays its part. Geography also plays its part as well. This, coupled with temperature, can create certain kinds of winds. And we have one wind which will start at a mountain ridge or a hill ridge, and it will flow down into the valley, and that's what we call a katabatic wind. Okay, so what we have, colder air that is being cooled at a higher rate on the ridgeline, okay, and it will start to flow down because it's colder and heavier, and it will replace the warmer air into the valley floor. And these can be quite severe winds. They can be quite strong winds, I should say. Okay. Another type of wind is called what we call an adiabatic wind. Okay, it's essentially hot air rising out of, let's say, a valley floor, for example, and it's warm air, not hot air, warm air is rising, and then it can create this circulation process of cold air falling as well, convection currents type of thing. But that's the warm air rising. We can have similar kind of thing, above the surface, above any kind of surface, where warm air is rising, and we'll create thermals, so airflow going up. Okay, those are essentially what thermals are. So wind, air movement can be created by lots of different things. It can be created by pressure differentials, temperature differentials, air density differentials. It can also be caused by moisture content differentials as well. Again, these are not mutually exclusive, but mixed with all the other processes, all the other factors, the pressure, the temperature, density, moisture content can also have an impact as well. So wind is essentially the movement of air in any direction, horizontally, vertically upwards, vertically downwards, diagonally down a ridge line, meandering upwards as in a thermal, or soaring upwards, so on and so forth. Okay. We can also have winds created by cloud formation and thunderstorms as well, thunderstorm dissipation. So look at my other videos on how different types of thunderstorms, but essentially as warm air rises, as it condenses out, it may generate an upward motion of air still rising. Okay, and this is to do with the latent heat exchange of how as water molecules condense out, they have to release heat energy. So release heat energy, therefore the ambient atmosphere tends to warm up a little bit, and it continues this process of warm air rising within the cloud formation. So you get an updraft of air, therefore there's a wind going up. Downdraft, exactly the same, where you have condensed water molecules that become heavier than air, and so they start to fall. As they start to fall, they create a downflow of air. This downflow, these downdrafts, can in the cloud can also escape through the bottom of the cloud, and they can be very powerful, very isolated, and very rapid winds, and they're called microbursts. Now they can be associated with rain and things like that, but these are just rapid airflows down. So that is a wind, if you like, in inverted commas. The air movement is probably a better term, created by the convection process, the cloud formation process, the thunderstorm process as well. So pressure, temperature, density, moisture, cloud formation. Lots of different reasons why wind is formed and what causes it to form. Now, all over the world, just one final thing, all over the world, you will have local winds, okay? Local winds which the local people will have a specific name for. Essentially, it's still the same process. It's still air movement. However, it might be like a Scirocco wind or whatever it is. It's a Ural wind or whatever. A Rocky Mountain wind. Whatever it is. Essentially, they're describing a wind that is a common wind type in that particular geographic location. Usually it is determined by the geography. If it's a mountain range, is it close to the sea? What time of year is it? That kind of thing. So you will have local winds or regional winds that might have different names by the local people. But essentially it's still the air movement. Okay. Right. Thank you very much.